All right. Good day and welcome to this module. So we're looking at module 10, IPv4 and IPv6 address management. So I'm going to be explaining the network boundaries, network address translation, IPv4 issues, IPv6 features. First, let's look at the network boundaries. All right. So you need to understand that routers are used to connect different networks on the network, right? So um, each router interface connects to a separate network, all right? So for example, different group of systems can be connected to each other, and those group of systems can be connected to different interfaces on a particular router. So the IPv4 address assigned to the interface is the um, default gateway address of all hosts connected to that same network. So for example, now if this host here is connected to an interface on this router, let's assume this is belonging to a particular network. Let's assume we have other hosts right here. Okay, so the host connected to an interface here. So that interface that the host is connected to is going to be regarded as a default gateway of um, those particular hosts on that particular network. All right. So now just I remember that those hosts are connected to a switch and the switch is connected to the router. All right. So hosts commonly get the IPv4 address using the dynamic host. All right. So now you can have um, the DHCP client, which is going to be connecting its IP address automatically using the word DHCP server. All right. So now, so routers can serve as boundaries between networks. All right. So you can see here we have uh, different DHCP clients here connected to the router. So the router is kind of separating this particular clients or host machines on its network from the main internet. Alright, so a wireless router commonly provides the IP address information for local internal hosts. So routers that connect to the internet commonly get addressing information using the DHCP from the ISP. Alright, let's look at network address translation. Alright, so network address translation is used to convert IP addresses used within a company to a public global address that can be routed on the internet. So let's assume this is a network on a company, so connected to the router, alright. So this company is connected to an interface on the router, alright. So the router is connected to the public internet. So for before a message is being requested from a server, right? So that particular the source IP address is going to be translated into a public IP address, right? So those public IP address are this public IP address, alright, is being recognized or being sent through a port on the internet. So one public IP address can be shared among many private IP addresses through the use of port numbers. Alright, so there's a packet tracer lab attached to this. So let's look at IPv4 issues. Alright, so because IPv4 has its limitations, which is due to the maximum amount of users. Alright, remember IPv4 when using network address translation, it causes latency and has some limitations. So and another thing is that because of the introduction of IoT devices, alright, IPv4 addresses are being exhausted. So therefore, they have to move further to IPv6 addresses. So we're going to look at something now. Look at IPv6 address size. So IPv6 address can range from thousands of users to even what on the zillion number of users. I know that the people in the world are not even up to a quadrillion yet, but devices in the world, because technology is fast evolving, so more IoT devices are being um, introduced into the internet. So we needed more space, and IPv6 can almost um, provide make provision for the amount of IP addresses that are needed by those IoT devices. So now, um, there's something called dual stack. All right, so dual stack allows IPv4 and IPv6 to coexist on the same network segment. So dual stack devices run both IPv4 and IPv6 protocol stacks simultaneously. So known as the native IPv6, this means that the customer network has an IPv6 connection to the internet service provider and is able to access content found on the internet over IPv6. All right, remember when you do ipconfig on your host machine, all right, you see both an IPv4 address and IPv6 address. So that's an example of a dual stack PC. All right, so there's something called tunneling also. So tunneling is a method of transporting an IPv6 packet over an IPv4 network. So the IPv6 packet is encapsulated inside an IPv4 packet, similar to other types of data. So that particular way of sending packets via using an IPv6 address, okay, through an IPv4 interface is called what? Tunneling. So you can see here, this is an illustration of tunneling between two dual stack routers that connects to IPv6 net, connect IPv6 network only. So tunneling can also be done through different pieces, all right. Okay, so you can see that here there's tunneling between IPv6 only network and IPv4 only network. Just like you can see that this PC1 here connects to the internet, all right, the router via an IPv6 IP address, and this other PC here uses what? An IPv4 IP address, but yet communication is still possible. So let's look at IPv6 features. So IPv6 um, configuration and link local addresses. So there's something called the stateless address auto configuration. So it allows a host to create its own internet routable IPv6 address without the need of a DHCP server. So local link address is used to communicate with devices on the same IPv6 local network. So here you see that the router solicitation to all IPv6 router. So here this PC is saying what I need addressing information from the router. So the router now what sends to all IPv6 nodes, says here is your prefix length default gateway information. It sends it to both the host and the DHCP server. So now yet for IPv6 have been um denoted by 16-bit sections. All right, so the maximum um letter here, because it's in base 16, you have what? FFFF. All right, that's the maximum number of letter here that we can have on this point. So you can see here now, instead of even having 0 db8, all right, you can have just db8. Okay, so now when this is an example of an IPv6 address that is fully expanded, all right, so instead of putting 0000 ratio 0 ratio 11, you can just use one single zero. All right, then also instead of putting what 0200, you can have just what 200. Then also when you have a nested number of zeros, like here we have 4 zeros ratio 4 zeros ratio 4 zeros, so you can also use that as what ratio 0 ratio 0 ratio 0. Right, or you can just cut out all the zero and just make put what double column and have your 200. So this is a compressed IPv6 IP address or IPv6 address. So there's a lab connected to this. All right, so we can see we've understood that routers are used to create network boundaries, and you understood what tunneling is. Okay, that that's what enables um, dual stack um, devices to connect over the same network with IPv4 devices. All right. You also understood what network boundaries are, what network address translation is. You see that IPv6 are hexadecimal. All right. Also, you understood what stateless address auto configuration is, and you understand how to segment the different zeros on an IPv6 address. All right. Now, let's look at the module 11, transport layer services. So I'm going to be explaining the client-server relationship, the TCP and UDP. All right. The port numbers. So I'm going to understand what port numbers are. All right. So you see, understand how the TCP and the UDP use port numbers. All right. So the TCP stands for Transport Configuration Protocol, and the UDP stands for um, User Datagram Protocol. So look at the server and client relationship or interconnection. So we use network services available over the network and internet to communicate with each other. So the server is a host running a software application. So the software application can be regarded as the service which that server is um running. All right. So there are millions of servers on the internet, and clients and servers interact following agreed upon standards and protocols. And take note, you have to note that a server can run different services. So a server that runs an email service can also run a web service at the same time. Right? It can also run a file service at the same time. So the different kind of services that we have are email services, web services, and file services. So email services runs the email server software. All right. So clients use the mail client software such as your um, Gmail, all right, so Microsoft Outlook, okay, mail to access emails from the server or communication, establish communication with another person on a mail server. Then the web server runs the server software. So okay, so that's what enables you to browse the internet. So when you just type open your Internet Explorer with your web application, just type www.google.com. So you have made a request to a Google web server. All right. So we also have file servers. So file servers help you to store corporate and user files in a central location. And for you to use a file server, you need to have um or go through platforms like the Windows Explorer, Google Drive, alright, that enables you to what? Use this file server. So here you see that how a client, you see how understand how a client requests web pages. Alright, so when a person uses the web browser to access the web server by sending a request, alright, for example www.google.com, so the server receives the request and responds by sending the requested web page back to the client. So you can see that the message is being transported through internet service providers. Alright, so from internet service providers to the internet, jumping from one router to another, and gets towards the servers, okay, in a data center, and automatically the web server um, picks up the request and sends back a reply. So there's something called the URN. All right, URN stands for resource uniform resource name. So it identifies only the namespace of the resource without reference to the protocol. All right, so the URN is what, for example, www.google.com/author/book, and say example.com/slash dot book.html. All right, so now this is a URN. Then there's also something called the URL, which we are used to. All right, so it just defines the location of a specific resource on the network. So this actually carries a kind of protocol. For example, this is HTTP, Hypertext Transfer Protocol Secure, right? The S there stands for secure. So there are components in a URL, all right? We have the protocol or scheme, which can be HTTPS or HTTP, or can be FTP or SFTP, or mail to or NNTP. Then you have the host name, which is, for example, we have www.example.com. So that is the host name. Then the path and file name, which is what the path of that particular page in within that host. All right. So we have author slash book.html. Then a fragment is the present page, all right, or your own. Let's assume you're accessing a PDF online, all right. A fragment can be regarded as the different pages on that PDF on the web. So there's a package yourself file attached to that section. So let's look at the TCP and the UDP. So a web server and a web client use specific protocol and standards in the process of exchanging information to ensure that the messages are received and understood. So the various protocols necessary to deliver a web page function are the four different layers of the TCP/IP model as follows. So the TCP/IP model with the protocols that work in TCP/IP model are the application layer protocol, transport layer protocol, internet layer protocol, and the network access layer. All right. So the application layer protocol, all right, for example, the HTTP governs the way that the web server and the web client interact. All right. Then the transport layer, all right, or the transport protocol, which is the transmission control protocol or a TCP, ensures that IP packets are sent reliably and any missing packets that have been sent before that didn't get to the destination, so the destination hosts are being resent. All right. Then the internet network layer protocol, which is the most common, um, which is IP, okay, which is internet protocol, is used to identify end hosts and route packets to destination hosts. All right. So it's internet protocol that enables that particular information to be sent from one host to another. Then the network access layer. So the specific protocol at the network access layer, such as the Ethernet. All right. So it can be Ethernet, it can be wired. All right. It's dependent on the type of media and transmission methods used in the physical network. All right. When you see media, how is this information being sent? Is it wired? Is it wireless? All right. If it's wired, it means that it's via an Ethernet cable, right? So it's depending on the network interface card, all right, that the host machine has. So a network interface card can either be a card that requires a wired connection or a card that requires what a wireless connection. So each service has its own application protocol that are implemented in the server and client software. All right. So in all common internet services, they use what the internet protocol to address and route messages between source and destination. All right. So you can see the IP now. All right. Then we also have the TCP and UDP. All right. So the service application decides which transport protocol to use. All right. So protocol specify how to manage the transfer of messages between hosts. All right. Which is either going to be what TCP or what UDP. We'll be looking at into that very soon. Then the most common transport protocols are the TCP and the UDP. All right, now remember I said this transmission control protocol and the user datagram protocol. Then let's look at TCP reliability. So TCP helps to ensure reliable delivery of data packets. All right, so it says here that TCP breaks up a message into smaller pieces called segments. All right, so segments are numbered in sequences, all right, and passed to the IP process for assembly into packets. So the TCP tracks the number of segments that have been sent. If the sender does not receive any acknowledgement within a certain period of time, it is assumed that that segment was lost during transmission, and that missing portion will be what sent again. So on the receiving host, the TCP is responsible for reassembling the message segments in orders and passing them to the application. Then for the UDP, all right. So in some applications now, reliable delivery is not required. All right. So there's no need to verify whether the information gets to the end user or not. And that is where UDP will be appropriate to use. All right. So UDP is a best effort delivery system that does not require acknowledgement of receipts. All right. For example, when you send somebody a text message, you do not usually check whether the person has received it. You do not usually check for receipt whether the person have received the text message or not. You just assume the person have received the text message. So UDP is preferable with applications that use time sensitive technology such as streaming video, voiceover, and voice over IP calls. All right, so that's VoIP. So another example is when you're making calls. All right, um acknowledgement would slow down delivery and transmissions are what undesirable. So when using um UDP, there's something called handshake. Handshake is just an approval, just like you have on WhatsApp. When you send a text message to someone on WhatsApp, you see a double check, a double um tick, all right, to show that the person have received. First of all, it is not color to show the person have received the message, and when it gets color, it shows that the person have what read the message. So, but when making phone call, there's no way to verify whether the person has heard you or not, except the person sends response to your message. All right, so there is nothing to check to tell you if the person has heard your voice or not without the person not responding back. Because if you were to hear, all right, you say hello, and the person on the other end has heard you. Imagine hearing between the call, you say, okay, the other person have heard what you said, or the other person have received your hello. That will make calling a little bit more ambiguous, all right, and would waste a lot of airtime. Let's look at port numbers. So when a message is delivered using either a TCP or UDP, the protocol and service requests are identified by a port number. So a port number is a numeric identifier which each segment that is used to keep track of specific conversations between a client and a server. So every message that a host sends contains both a source and destination port. So the ports are assigned to and managed by an organization called the ICANN, the Internet Corporation for Assigned Names and Numbers. So ports are broken into three categories, right, of ranges. So we have the well-known ports, right. So well-known ports are destination ports that are associated with common network applications. So these ports range from what 1 to 1023. Then there are registered ports. So registered ports are from 1024 through 49,151, and they can be used as either source or destination ports. Then there are private ports. So private ports range from 49,152 through 65,535 and are often used as what source ports. So these ports can be used by any application, but registered ports can be used as either what source or destination ports. So these are some common well-known ports. You can see port 20 for FTP, port 21 also for FTP control, then port 22 secure shell SSH, port 23 for telnet, port 25 for simple mail transfer protocol, port 53 for domain name services. All right, we have 67 for DHCP servers, 68 for DHCP clients. We also have um 69 for triv- trivial FTP, all right, 80 for HTTP, 110 for POP, which is Post Office Protocol version. Remember, when setting up a mail, you choose whether you use POP or use an IMAP. So port 143 for Internet Message Access Protocol, right? 161 for Simple Network Management Protocol, and 443 for HTTPS, which is Hypertext Transfer Protocol Secure. So let's look at what destination and source ports are. So the source port number is associated with the originating application on the local sending host, and the destination port is associated with the destination application of the remote host. Now, when you say a local sending host, that's probably your system, all right? Then the destination application is the probably the application that the server is running. So the source port, all right, dynamically generated by sending service to identify a conversation between two devices. So this process allows multiple conversations to occur simultaneously. So destination port, which is the client, means that the client places a destination port number in the segment to tell the destination server what service is being requested. All right. Remember, a server can be running FTP, um, HTTP, or what, um, mail services. So the port number that is being used to send that particular request will let the server know what kind of service you're offering. All right. So if the port number is 80, the web server knows that is what um you're requesting for a web page. All right. So if it's 110, you need an electronic mail. So the source and destination ports are placed within the segment um PDU. All right. So it is encapsulated within an IP packet which contains the IP address of the source and destination. So the combination of the source IP address and the source port number, or the destination IP address and destination port number, is known as a socket. All right. So now you can look at this example here. All right. This example here, the socket is used to identify the server and service being requested by a client A. All right. So this is the client, and you can see it has a source port, all right, which is what, 1305, which tells the server that it was requesting a file transfer protocol. So the server now receives the port in what, sends the port request back in what, port 20 to port 21, which is going to go through that same way back to the system. All right. Now together these two sockets combine to form a what, socket pair. So we have here 192.1.1.5 ratio what, 1099, right, and 192.1.1.7 ratio what, 80. All right. So where the 1099 is the source port and the 80 is what, the destination port. So the source port number acts as a return address for the what, requesting application. So there's something called the netstat command on your system. So if you open your command prompt and you type netstat, all right, it shows you the list of active connections on your systems. All right, all the different services that are running on the network. All right, whether you see whether it's a TCP or UDP, FTP, all right, or a mail service running. So here now you see that there is the highlighted 191.1.124 ratio 3160 and same thing ratio 3159. All right, and you see that they are making requests on the same URL, which is 207.138.126.169 HTTP. So here you can see that the PC is generating two different source ports to maintain these two web sessions. Alright, which is one has to do with destination and the source and destination. One is the source, the other is the destination. Alright, we fully understood how server and clients operate on the network. So that when you server runs different softwares or different services, which could be a mail service, alright, a file service, alright, or a web service. Alright, you understand what the difference between TCP and UDP is. Alright, so TCP shows a or tells you whether the other end device have gotten the message or not, or UDP do not well, tell you if the other person have received the message or not. Alright, and UDP is a best effort delivery system that does not require acknowledgement. That's what I just talking about. So there's no acknowledgement to UDP, but there's acknowledgement in TCP. So you need to refresh and go back to study what TCP means. All right, what reliable delivery system is in TCP. All right, why is TCP a reliable delivery system? All right, read more about the user datagram protocol, understand the best effort delivery system. Okay, read more about ports, all right, socket pairs, and understand the netstart command very well. All right, so we've come an end to today's session. See you in the next class.